Hi guys. I am gonna have to do your 9.1 video for the beginning. This actually split into two parts, but I just thought it would be a good way to do this through Zoom. And I just want to say hey, and I hope to see more of you on Wednesday at 11. If you need it, I know the lessons have probably been pretty easy because I'm really just sticking to one topic for the week and something that I feel like you can do on your own. Try not to make it too difficult. But I did want to introduce to you a new family member that we got yesterday. This is Rebel. I don't know if you can see him. There he is. Rebel. Hi. He's a good little doggy, he's 11 months old, and we just got him yesterday. So we're enjoying him. But anyway, I'm going to take the video off and show you the lesson here in just a second. And so this is the exciting thing, is that we are going to Trig. So we're finishing out the year. We might do a little bit more statistics, but we're really finishing out this year with Trig. And we're just going to go slow. So this week's going to be easy. Next week's going to be easy. And then I'll try to keep them the best way I can, knowing that you're having to do them by yourself at home. So what it will do is give you some basics for when you do get ready to go into your next year's class, because you're going to go past the basics next year. So it'll at least give you something to start with. All right, so what we're doing here is we're working with regular right triangle trig, which is, like I said, the basics. And so you're going to learn this word here. It's not really a word. It's a mnemonic device, and it's very important that you know how to spell it correctly because it's used for everything in right triangle trig. So you want to know how to use it and how to spell it. Okay, and then so what we'll do is we'll start in the workbook here on page 244 in your notes. You're going to see the basic 6 trig functions. So there's sin. Sin is how you say that, not sin. It's a sin to call it the wrong word. It's sine, cosine, and tangent. And every right triangle, I'll draw one out here for you. Every right triangle has, you're going to label the sides for it. So across from the 90 degrees is always the hypotenuse. Okay, and then depending on which angle you use, and this little symbol right here is called a theta, and that's what we use in trig. So if I have my theta here, then my opposite side would be the opposite from the theta. Hypotenuse never changes, but the opposite and the adjacent do. So the opposite would be across, and the adjacent would be beside. So look like that. Okay, now let's change, let me do a different color here, and let's actually change out, do the same triangle basically. Here's my right angle, which means my hypotenuse has to be across from that. And let's say my theta was here. Now in that case, the opposite is going to be this side, and the adjacent is going to be the one that's beside it, like this. Okay, so the first thing you have to be able to do in trig is to find the adjacent, opposite, and hypotenuse of every right triangle. That is the only way that you can find sine, cosine, and tangent, which are your 3 basic trig functions. And then they have what's called a inverse function. So sine's inverse is what we call cosecant. And so all it is it's the flip. If this is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So they just kind of flip-flop from each other. Cosine, which is this one, is adjacent over hypotenuse, and so it flips for secant, which is hypotenuse over opposite. So they just kind of invert, basically. The tangent is opposite over adjacent, and so the cotangent is the flip of that. So once you learn the first 3, the co-functions come in pretty easily. Let's see. So what we need to talk about is SOHCAHTOA and how to write it and what it stands for. So this is a way to remember sine, cosine, and tangent. So if I had, first let's write it out. So it'd be so it's sine that stands for sine, is opposite over hypotenuse. So that's how you read it. The sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. And if you look here, that's exactly what this says. The cosine is adjacent over hypotenuse. And then the tangent is opposite over adjacent. So tangent, if you look here at your notes, tangent is opposite over adjacent. So once you learn how to spell SOHCAHTOA correctly, and then how to use it, all of trig can be very, very simple, especially the right triangle trig. All right, so let's try a couple of examples. I have on this next page here, this is on page 246 in your notes. I'll be asking you to do just the first 4 things off of this page. What you'll notice in the bottom where you're solving right triangles, that will be next week. All right, so what they want us to do is to label the 6 trig functions. So notice where theta is, and notice where my right angle is. So I could, if I wanted to label this, I could. So across from my right angle over here would be my hypotenuse. Across from theta is going to be my opposite. And then beside theta is going to be my adjacent. Okay, so now that I know that, I can really list out all 6 of the trig functions with no problem. But what you'll notice is that I'm missing a side. So what I've got to do is just use regular Pythagorean theorem. So the Pythagorean theorem is a squared plus b squared equals c squared. And if you remember, c is always the hypotenuse, so that's the thing I'm looking for. So I'm going to make 8 my a, 15 my b, and I'm solving for c in this case. So we're going to do let's see, hold on. So we're going to do 8 squared plus 15 squared, which would be 64 plus 225, I believe. Hold on, let me try it again. 15 squared plus 64. That's going to be 289. I'm going to go ahead and square root this while I have it there. Okay, so it ends up with being 289 equals c squared. And when I square root that, I get 17. Okay, so this side over here is 17. Once I have all 3 sides, then I can label the 6 trig functions. Okay, so that will go like this. You're going to start with, make my pen just a little smaller, so I got not a lot of room here. All right, so we're going to do sine. Always start with the sine, cosine, and tangent. So sine of theta, so here's my theta. Remember that in SOHCAHTOA, sine is opposite over hypotenuse. So you're going to label the opposite, which is 15 in this case, over the hypotenuse, which is 17. Okay, and then for the cosine theta is, that's the part of SOHCAHTOA. The cosine is adjacent over hypotenuse. So we're going to take the adjacent side, which is 8, over the hypotenuse, which is 17. Then we're going to take the tangent of theta. Again, these are the 3 basic trig functions. The tangent is opposite over adjacent, so SOHCAHTOA. So opposite over adjacent. In this case, the opposite of is 15, the adjacent is 8. So once you have the sides, again, like I said, you just kind of put them in the right spot. Okay, so now we need all the other 3, which are the cofunctions. The cofunction to sine is called cosecant, and that is just the flip. So if this was opposite over hypotenuse, then the cosecant is going to be hypotenuse over opposite. So that will be 17 over 15. The cofunction for cosine is actually secant. And so secant will be 17 over 8, looks like. And then the cofunction for tangent is what's called cotangent. And that will be 8 over 15. Okay. And then we're done. So that's all this first part is asking you to do, is to solve the 6 trig functions. And there they are. So what I'd like for you to do for number 2, these you're going to be studying or practicing a lot of these this week. If you would, go ahead and pause the video, try number 2 on your own, and then come back and check when you're done. Or I'm sorry, play the video again when you're ready to check yourself. All right, so this theta, notice where theta is. That means across from 90 is my hypotenuse. Across from theta is the opposite. And then this number over here that's missing is going to be my adjacent. So my job is to go find that. I'm going to start with, like we did before, a squared plus b squared equals c squared. I can use that because it's a right triangle. A in this case is what I'm looking for. B is going to be 4. If you remember correctly, A and B are always the sides that are not the hypotenuse. The hypotenuse is always C. And since I know that this time, that's going to be 8 squared. Okay, so I have A squared plus 16 equals 64. So A squared is, let's see. Oh, goodness gracious. It's because I'm trying to hurry that nothing's working out. What am I trying to do? 64 minus 16. Good gracious, it's 48. All right, so we're going to square root both sides. Now remember back to square roots when you could break those down. This is something that actually can be broken down. So square root of 48, oh, what happened? Let's go. Square root of 48 would be, I believe 16 goes into that. 3 times, right? Oh my goodness. Yeah, so 16 and 3. So if I broke this into, look at it like this. Square root of 16 times the square root of 3. That would make it 4 times the square root of 3. They're going to want the breakdown. So any work that you're doing in this, if you get stuck on it, let me know. But you are going to have to work with rationalizing. That means you can't have a radical in the denominator. And you're also going to have to break down square roots like this. So that's the hardest part of what we're doing. Obviously, the idea is very easy. Okay, so that means this side is going to be 4 times the square root of 3. Okay, so let's go ahead and start writing these out. Though, let me change colors so you can see the difference between number 1 and number 2. Okay, so if I had, now that I have that third side, I can solve for sine theta. Remember, sine is opposite over hypotenuse. So from theta, my opposite is 4, and my hypotenuse is 8. Now, we always want to reduce when we can. So obviously, that's going to be 1/2. Okay, then we're going to go on to the cosine. Cosine is going to be adjacent over hypotenuse. The adjacent is going to be 4 square root of 3 over the hypotenuse of 8. Now notice the square root of 3 is in the numerator. That is perfectly fine. It's when that's in the denominator that we're going to have to do a little bit more work. The only thing I can really reduce here is my 4 over 8 again. So I'm going to make that square root of 3 over 2. It's like 1/2 times square root of 3. All right, then my tangent. Tangent, remember, is opposite over adjacent. So we're going to do the opposite is 4, and the adjacent is 4 over square root of 3. I'm sorry, 4 square root of 3. Okay, so first let's reduce that. This 4 over 4 just reduces to 1. So it's 1 over square root of 3. Now this is the case where I was saying that this is illegal. You can't have a square root of 3 in the bottom. So if you remember back to rationalizing, we did this quite a while ago, but I'm sure it'll come back to you. And what we have to do is multiply top and bottom by square root of 3 because we can't leave a radical in the denominator. So if we multiply the top by square root of 3, we've got 1 times square root of 3, which is square root of 3. And then square root of 3 times square root of 3, which is square root of 9, which is just 3. So what that does is it takes out the square root by multiplying it by itself. So this is the answer that we get for tangent. Okay, now we've got to go back and list the other 3. So right beside sine, I'm going to use cosecant, which is its flip. So if, let's see, if sine is opposite of our hypotenuse, I'm going to do hypotenuse over opposite, which would be 8/4, which is just 2. Same thing for secant. Secant is the flip of cosine. If cosine is, let's see, if I just take this answer and flip it, I'll have 2/√3. Now we're going to have that same problem, though, where the square root of 3 is in the denominator. So I've got to multiply top and bottom by square root of 3. On top, I would be left with 2 square root of 3. And on the bottom, square root of 3 times square root of 3 is just 3. It's actually a square root of 9, but square root of 9 is 3. And that's the whole point in rationalizing. Now for the tangent, we're going to do the cotangent. And if I go back to just the reciprocal of opposite over adjacent and do adjacent over opposite, I don't have to rationalize anything. So I'm going to do the adjacent, which is 4 square root of 3, over the opposite, which is 4. And then all I really do is break down this 4/4, which is just 1. So that answer would be square root of 3. So you're going to have 6 different answers, 1 for each of the 6 trig functions. Okay, now let's look at this last type that you'll have to do here. It's basically the same, but it's giving you some information. It's saying, look, tangent is going to be 1. So what that means is I'm going to draw out a triangle and put a theta somewhere. It can't be the right angle, but it can be one of the other angles. So we'll put our theta right there. If tangent is 1, that means 1/1. So I'm going to do, if it's, I like to write SOHCAHTOA at the top of every paper that I work on, so I have it handy. If I was going to do a tangent, remember, is opposite over adjacent. So from theta, I'm going to do the opposite is 1, and the adjacent is also 1. So what it does is it gives me information. So like when you do number 4, you're going to start with a right triangle, put in your right angle, and this one is sine. Sine is opposite over hypotenuse. So if I put, let's say I put my theta here, it doesn't really matter where you put it. This time we'll put it up in the other acute angle. The opposite would be 3, and the hypotenuse would be 19. And so that's how you'll start these problems. And then after that, it's really just like the ones above that we did. Okay, so let's start solving it then. Here we're going to have to work Pythagorean theorem. 1 squared plus 1 squared equals c squared. That would be 2 equals c squared, square root both sides. So c is the square root of 2. Okay, this is actually a very important triangle for trig, which you'll find out about later. This is a 45-45-90 ratio. But all right, so anyway, so if we started with the sine, sine again is opposite over hypotenuse. That would be 1 over square root of 2. And once again, we can't have the square root of 2 in the denominator, so we're going to multiply top and bottom by square root of 2. So up top, I would have square root of 2, and on the bottom, I would have 2. So my answer ends up being square root of 2/2. Then for the cosine, that's going to be the same, really, because it's just the adjacent over hypotenuse. I still have to rationalize. I get square root of 2/2 again. And then for the tangent will be opposite over adjacent, so that would be 1/1, which is just 1. And now my trig functions, cosecant is the flip of sine. If sine was opposite over hypotenuse, I'm going to do hypotenuse over opposite, which would just be square root of 2/1, which is square root of 2. The secant will be the flip of cosine, which is adjacent over hypotenuse. So I'm going to do hypotenuse over opposite, gives me the same thing. And then the cotangent is the reciprocal of opposite over adjacent, which would be adjacent over opposite, which is still 1. So now when we solve number 4, again, you can pause and play. Pause, try it by yourself, and then play it if you like. But it looks like we have a squared is what we're looking for. We have b, which is 3. And we have c, which is 19. All right, so give me a second here. I'm sure this is going to trying to use my other computer to figure this out. So if I did 19 squared is 361, and then I'm going to subtract 9 from that, which is 352. Oh, that's a big number. And then we need to square root that. So let's see what goes into 352. Okay, looks like 16 and 22, which would be 4 square root of 22. There's got to be some. Is there something else that goes in 22? I don't think so. There's not another perfect square that goes into 22. 22. Oh, good Lord. Let's see, 22. Boy, I don't like these calculator on the computer calculators. Yeah, we're going to leave it with square root of 22. There's nothing that goes into there. So we have, once we square rooted both sides, we would end up with 4 times square root of 22. Okay, so now that's going to be this side. So we're going to start with our sine. The sine they already gave us. That's 3 over 19. So we can go ahead and find the cosecant, which is the flip of that. And the cosine is going to be adjacent over hypotenuse. And then the cosecant now we don't like that square root of 22 being in the denominator. I'm going to come down here and fix that. So if we multiply by square root of 22 like that, we would have 19 square root of 22 on top. On the bottom, we'd basically have 22 times 4, which would be 88. And we could just leave that for now. Then the tangent of theta is opposite over adjacent. So that will be 3 over 4 square root of 22. Again, same thing. That will be 3 square root of 22 over 88. And then the cotangent is going to be actually adjacent over opposite. So it'll be 4 square root of 22 over 3. Okay, so the whole idea, everything that we did here was understanding SOHCAHTOA, how it's written, and then using it to solve any right triangle and finding those 6 trig functions. And then once you found those 6 trig functions, then you can do lots more with trig. So this is really, like I said, this is the basics and just kind of getting you prepared and ready. Let's see if I can go back to here. So thank you guys for watching, and if you run into any problems, I'm assuming that the hardest part is going to be the radicals and the square rooting. So like I told you before, you can always take a picture of your work and text it to the number that I have. I'll put that on the OneNote again for this week, so you have a reminder of that. You can always text it. I might not get to you right away if it's not during my normal work hours or I don't have my computer on, but I will try to whenever I can. So anyway, good luck, and let me know if you guys have any questions, and happy trigging. Oh, wait.